Hi everybody, welcome to your week 7 lesson 1 for maths. This is for year 6. Today it's all about data and specifically interpreting two-way tables. Okay, to interpret two-way tables, there's a few things you need to do. Firstly, you need to understand that two-way tables are about showing the relationship between data. So we have different types of data, which is just another way of saying information. If you'd like a little bit more of an explanation about data, feel free to watch the year 5 video, but essentially it just means information. We can have data about anything really. You're looking at maybe 2 different types of data in the same table. You need to be able to read the table's title. So that seems really basic, but you want to make sure that the data you're reading is the data you're looking for. And the best way to do that is to look at the title. So every good table should have a title. You'll also need to read the column and row headings. And also, because we're looking for the relationship, we're comparing the data in different columns and or rows. So I'm going to do that in a moment, just as an example, and that's what you're doing today. So here's our first set of data, and it's taken from the Australian Census, which is a survey that's conducted every 5 years to collect information about people who live in Australia. It's everybody. So that can be adults and children. Basically, adults fill it in. Anybody who's under 18 doesn't need to fill it in, but the adult in your household at the time will fill it in and cover off your details. So this information is about the top 5 countries of birth. So this is where people in Australia were born. And it's looking at the 2011 census and the 2016 census. Now we just did one, the 2021 census about a week or 2 ago. That data won't be available for quite some time yet. It does take them a while to process that and clean it and present it. So we'll have to wait a little bit for that. But this is the most recent data we have now. We're going to compare 2 years. So we've got our table here and we've got our 2 columns. So the way this has been set out is that there's 1 column for 2011 and 1 column for 2016. We have the country of birth here. So this is where people in Australia were born, whether they were born in Australia, England, somewhere else, and these are the top 5 countries. So obviously there are a lot of countries in the world, and people who live in Australia, can be born in any of those countries and move here. But these are the top 5 ones, the most frequent ones. So here we've got percentages, and that's percentage of the population, of the total Australian population. And here there are numbers, which are just the number of people. So one of the advantages of two-way tables is we can compare different pieces of data. So firstly, if we just looked at the 2011 column, we can compare between the countries of birth just in 2011. So we can go, okay, well in 2011, most people were born in Australia, so 69.8%. Then the next country that people were most likely born in was England, and that's 4.2%. By adding an extra column though, we can actually start making some comparisons and sort of finding out some interesting data. So here, if I look between 2011 and 2016 on my Australian row here, Australia row, I can see that it's actually decreased. So the proportion of people who were born in Australia as a proportion of the population, so as a percentage of the population, actually decreased. And it decreased about almost 3.1%. So it's quite a significant, I wouldn't say significant, an interesting decrease there. Over here on the 2011 and 2016, here the actual number of people increased, and we can just account that the fact that the population is increasing as more and more people are born over the 5 years, but as a proportion of the population, it actually decreased. Whereas, and we can also see that it's the same case for England as well. New Zealand was roughly about the same, but for China here, we can see there's been a 0.7% increase between 2011 and 2016. And also here for India, we can see that it's increased by 0.5%. So we can say, well, for India and China, it increased for New Zealand, it stayed the same, and Australia and England, as the top 5 countries of birth, as a proportion of the population, that actually decreased. Now, it hasn't shifted the ranking of them, but that's the kind of comparisons we can make there between the years, as in 2011 and 2016, but also between the countries of birth, and make some comparisons there. So that's how a two-way table works in this instance. Here we've got Australia at the Olympics. So this is Australia's performance at the Olympics for the last 20 years. And it covers off 6 Olympic Games, including Sydney 2000. Now this table actually has a lot of information in it. So here we can see the number of athletes that we sent to each of the games. Now you can see in Sydney 2000, we had 630 athletes, which is the highest number of athletes we've sent to games in that period. But obviously that makes sense because we don't have to pay for travel costs, and it's in Australia, so of course the number of athletes is going to be higher. But then you can also look at the number of gold medals we got, and then the total number of medals, and then also the rank compared to other countries. So how we performed overall compared to other countries, what kind of rank did we get? Now, I'm not too sure whether that's based on gold medals or a calculation of the total, or whether each of these have a score attached to them. I'm not too sure, but that's the ranking. So here we can actually make some interesting comparisons as well. So here we can look at Athens and Tokyo. In terms of gold medals, they were our most successful games. And we also sent, after Sydney in 2000, which had 630 athletes, those two we sent the most number of athletes. Whereas for London and Rio, they had the lowest number of athletes, so 410 and 422 respectively. We had the lowest number of gold medals for those particular Olympics. Now we can see whether that really changes for the silver. You can actually make comparisons between the gold and the silver as well. So, well, even though we sent fewer athletes to the London Games, our silver was still pretty much the same as Beijing, pretty much the same as Athens. Whereas with Rio, it actually was lower than those as well. So you can maybe look at some sort of causation here and go, well, maybe if we send fewer athletes, that's the likelihood of getting medals is decreased. But here, it didn't really seem to affect the silver medal so much. And then you can also see how it affects the totals as well. So you could do that as well. So that's another way. So the way I'm doing this is I'm making sure that I'm looking at the row. So here are my categories, which are the different, well, actually these both come to two sorts of categories. So one category is the host city, and the other category is, the type of medal, or the number of athletes, actually the number of athletes, the type of medal. And I can sort of draw comparisons there by kind of moving across and looking for relationships between the different columns and rows and the different sorts of data. That's what we're looking for. We're not just looking at one column and just adding them all up and going, oh, well, we had the most number of athletes at Sydney. We're actually kind of looking between the different variables or different data, and maybe drawing some interesting conclusions there. Okay, so here in our last example, we have the life cycle CO2 or carbon dioxide equivalent that's produced by selected electricity supply technologies. It sounds super technical. Basically, it's saying that these are different ways of creating power or electricity, and this is how much carbon dioxide, a greenhouse gas, they produce over their complete life cycle. So that's from when all the materials for that power plant are made in the factory to when they're assembled, the power plant goes online, all the way through its operating time till the very end when it's actually torn down and put in a tip. So it uses this particular indicator. I'm not too sure. This is some numerical value. don't have to worry about that so much. Great. Basically, the higher the value, the more carbon dioxide it produces over its life cycle. Here we've got our technology in this column. So this is coal-fired power plants, gas power plants, solar PV, which are solar panels. You can have a solar power plant, so it can large scale, or you can have rooftop PV, which people have on their houses and we have at school. Geothermal, which is basically using the heat from underneath the Earth's crust to generate steam, which turns turbines. Nuclear power, and then wind onshore, which is wind turbines, which you might see if you've gone out into the regions. So we can see that coal has the highest minimum and highest maximum amount of CO2 it produces over its life cycle. This middle column here is the median, which is if we had all the coal plants in the world lined up, this middle one would be like if we had, let's say there are 2,000, we would have 1,000, actually so 999 here, kind of 1,000, and then I guess like 999 on this side as well. And this would sort of be right in the very middle. So that's our kind of median value there. So what we're looking at here, we can make some interesting conclusions looking at the different types of technology. So for example, here I can see that geothermal, even though it has a very low minimum value here, it has a higher maximum value than rooftop PV, which is only 60, but rooftop PV has a lower minimum value. Yeah, so the most efficient solar PV or rooftop technology produces 26, whereas the most efficient geothermal technology, which produces the least CO2, is 6. However, the most inefficient one produces 79, whereas the most inefficient solar PV rooftop produces 60. So I can make these interesting conclusions. Also here, this 6 value, this is very efficient. It's not producing a lot of CO2. Halfway between the minimum and the maximum, I have this 38, which is quite high, whereas there isn't such a huge difference here between 26 and 41, obviously because 26 is greater than 6, but still. Same here as well for wind onshore. That's quite interesting. So we've got 7, which is pretty good in terms of doesn't produce too much CO2. The median here is 11, which is also pretty good compared to the median for geothermal, but the maximum is 56, which is still lower than solar PV rooftop. It's still lower than geothermal. But it kind of suggests that there are more, tells me that there are more wind onshore plants that are between 7 and 11 here. So half of them are between 7 and 11, which is pretty good. Okay, so the main ideas from today: data means information. We can have data about anything, really. We can collect it in a lot of different ways. I suggest you watch my Year 5 video if you want to know more about data. The main thing, though, is two-way tables. They show the relationship between different types of data, and we can find the relationships by comparing that data, whether that's looking at data in different columns or data in different rows, or a combination of both. Now, today you won't have tables that are as complex as the ones I looked through in this presentation. You'll basically be using your skills to look either down the column at different types of information, or look across the row and compare information in this row here with information in this row here, or further along. So it's really about using those skills of scanning across, scanning down, making sure you're reading the right heading as well, and you're answering the question. It's not too tricky today, but I thought I'd show you some more complex examples to show you how powerful two-way tables can be. All right, guys, I'll see you tomorrow for lesson 2. Have a good one. Okay, guys, welcome to lesson 2 for week 7, year 6 maths. Today we are looking at creating two-way tables. It's going to be a pretty short lesson today. It's not too difficult. let's get stuck into it. Okay, so creating two-way tables, we need to make sure that the tables have columns and rows. That's one of the features of a table. Secondly, that you label your columns and rows with headings, so we know what the data in the columns means, and we also know what the data in the rows means. And lastly, making sure that when you input data, so you'll be inputting some raw data into tables, that's data that hasn't been sorted, it's just been collected, making sure that it goes into the correct row and column. Okay, so let's create a two-way table using some raw data. So that's data that's been collected, but it hasn't been put into a table, or it hasn't really been cleaned or sorted in any particular way. It's basically the first data grab that you get. It could be on the back of a napkin, on a post-it note. You might have an interview with somebody, so they might tell you what their preference is, and then you record it. It really comes in a lot of different forms. So here we've got one form of raw data. Basically, it's sorted in the columns and rows, but not in any particular order. So this question, the survey question or the research question is, what is the preferred device for playing games for 10 to 18-year-olds by their gender? So it's getting two pieces of data. Firstly, what is their preferred device for playing on? So whether that's a PlayStation, an Xbox, a Nintendo, a phone, whatever, and then their gender. So it's either, for this activity, it's male or female. Here, it might be, this is data that might have been gathered from an actual online survey. So each respondent, that's the person who replies or responds to the survey, gets an ID. One here for question one might mean that it's male, and then two might mean female, depending on the coding. Question two might be the type of device. So one might be Nintendo, three might be Xbox, four might be a phone, depending on how it's all set up on the online survey. So we've got two pieces of data. The first one is the device, and the second one is the gender. So preferred device and then the respondent's gender. So let's assume that this is for 2,000 people and it's split evenly between male and female respondents, because the thing we want to get maybe mostly from this is not, what's the most popular device. Like we could figure that out as well by calculating the totals of the male and female respondents for a particular device type, but also looking at the difference between what devices males prefer compared to females. By the way, this is all junk data that I've created, so it's not exactly representative. Here I've put it into a two-way table. I've made sure that I've given the table a heading so I know what this data is. So I put preferred device for playing games, brackets 10 to 18-year-olds by gender. So it's just, I haven't actually captured age data. Like I can assume, hopefully, that these people are of, either between 10 and 18. I haven't asked for their age because I'm not showing that on my table. Now, there are different ways of setting up this table. I could have male and female as my rows going across, and then I could have devices here, Xbox, PlayStation, and so on. The reason why I've set it up like this is because when you only have two rows, you have a lot of columns, so it actually becomes quite a wide table. This way, it seems quite tall, but it's actually longer than it is tall. So it sort of works better this way, only having three columns and then having more rows. You don't want to have too many columns. It's easier to track your eye to track down rows than it is to keep going across columns. So what I've done for this first column is I put the device type. So that's PlayStation, Xbox. So that's one piece of data that I want to know. Then I've got my gender data. So I've got one column for male, one column for female. And then this is where my counts come in. So, you could do this manually, or you could set up a formula to populate this. But here I can see that for PlayStation 4, out of 1,000 male respondents, 312 preferred PlayStation 4 over these other types of devices. compared to only 34 females. Whereas down here for phone, phone was much more popular with females than it was for males, almost double. So that's one way of setting up a two-way table. And then also down the bottom here, I've got the total. So I've got the total for the males here, which is 1,000, and total for female, which is 1,000 as well. So there's actually quite a lot of data here. We're not going to go through and interpret it today. Today, the main thing is you're setting up tables from raw data. So you might have raw data that looks like this. You might get it in another sort of format, basically creating your two-way table. So choosing what your headings are going to be, your column headings, and what data you're going to put in here. So here I've got my categories, which is my devices, and then these two categories, male and female for gender, are over here. So we've looked at putting data into a two-way table where it's given to us. So we had the example of the different devices and male and female. So we had two variables there, two different types of data which we can compare. Let's think about situations where we need to use a two-way table to start off with. So firstly, if I ask the class, what's your favorite color? I probably wouldn't need a two-way table because I'm just counting one variable there, one piece of information, which is people's favorite color. So we really just need one column. Well, we need two columns, one for the color and then one for the count. So 7 people like blue, 5 people like orange, and so on. Two-way tables are where we've got two variables or two different types of data that need to be captured. So let's think about a scenario. So imagine we're a gym owner and we really want to tap into this market of women over 30 coming to our gym. So we want to make sure that we have the right equipment, the right classes, the right setup to really attract that clientele. So the question we're going to ask is, what's the preferred types of gym exercise for women over 30? Now, there are two pieces of information here. Well, actually, there could just be one piece of information, and that might be, what's your preferred type of gym exercise? So we might go, yep, we're going to survey women over 30 and find out what their preferred type of gym exercise is. But I want to kind of narrow it down as well, because women over 30 is quite broad. There's women in their 30s, women in their 40s, all the way up to 80s, 90s, and so on. Very different needs and preferred types of exercises for those groups. So I'm going to think, well, actually, what's their age as well, or what's their age range? Now, because there are so many different ages, and I'm going for quite a broad group of people I'm surveying, I'm not going to go, okay, well, this is what all 31-year-olds thought, this is what all 32-year-olds thought, and so on, because one, I probably won't get enough people responding to the survey, and two, I could probably group them in categories or in age ranges. So what I'm going to do is I'm going to group them by kind of decades, so women in their 30s, women in their 40s, and so on. So the way I could present this in a two-way table, if I liked, is I could have my first column here on my left is the type of exercise or activity. And here I've got a few different options. I've got weights, equipment, classes, swimming. And here I've actually got a my other variable, which is age range here. And then underneath that, I've got all the options for that. So I've got 30s, 40s, 50s, and 60s. Then I could survey the people and then populate it with that information and then use this two-way table to inform my decision about, should I be offering more classes, or should I have more weights available or more equipment, and so on. Now, this isn't the only way I can present this table. I can also flip it around. So I can have the types of exercises here and then the age here as well. It's still going to tell me the same data. Of course, the numbers are going to be slightly different in terms of where they sit in the table, but they'll still be the same numbers and it'll still tell me the same information. So it's really just a matter of preference. Neither is right or wrong. It just shows you, how to set up a two-way table, but also when to use a two-way table. You only really need it where you've got these two different variables. If I was just finding out, what kind of the women who come to my gym, what age bracket do they fall in, then I'd only really need one column and I wouldn't need a two-way table. So here are the main ideas from today. Firstly, two-way tables are used when we have more than one variable or type of information. So for example, the device and people's gender, or their preferred type of exercise and their age range. Now you'll notice in that last activity, I didn't even include a column for gender because it was going to be all female respondents. So even though that's something I need to factor in when I'm gathering that survey data, I don't need to represent it in the table because it's already represented by the fact that everybody who's replying to that survey is female. Make sure your table has columns and rows, so important. Otherwise, it's not really a table, and they are labeled. Now, you saw that you could have one variable in this first kind of column, and then that would be going across on the rows. So for example, we had our types of exercise here. Then we had our age ranges up here as the columns. It doesn't really matter which way it goes. It's really what fits best. There is no particular sort of rule for that. As long as one of them is the columns and then one of them is the rows. Make sure your variables don't kind of mix them up. Obviously, input the data into the correct row as well. That kind of goes without saying. And lastly, one thing I didn't really look at was try to avoid having more than one type of data in each cell. So that's in each box. You don't want to kind of be mixing data. You really just want to have one number in there. You don't you could have a number and a percentage. It does make it a little bit trickier to read. It's probably better to have two separate tables for that. So really just try to make sure that there's only one type of number or value in each of those cells, and you should be good to go. All right, thank you for listening today. I'll see you tomorrow for the last lesson of the week. All right, bye-bye. Hi everybody, welcome to week 7, lesson 3 for year 6 maths. It's a Wednesday. This is your last lesson for the week because tomorrow we have the school disco and then Friday's a catch-up day. Today you're looking at interpreting side-by-side column graphs. Okay, so today we are learning to interpret a side-by-side column graph. Now you'll notice I've written this word interpret rather than just read. So read, your eyes can track up and down, you can count the numbers. Interpreting is actually giving meaning to something. So making sense of it and finding out what's the important information or important data that this graph is telling us that we can sort of use to help inform our decision making or whatever we're going to do with the data. So that's the difference with just reading and interpreting. Interpreting, you're giving it meaning or finding the meaning. Your success criteria today, so the first thing you'll need to do is make sure you consult the graph's key. So each of these graphs will have a key, and that's because we have more than one column. So we need to be able to distinguish between our columns on the graph. The next thing is compare the heights of different bars in the graph to make statements about the data. So with a column graph, as you'll see, we have our different columns or our bars. Sometimes I'll just use those interchangeably. And you want to look at the difference between them to actually make some statements about the data. That visual difference will help point out where you need to look. The larger the difference, probably the more important that piece of data is. A really easy way to make statements about data is to look for the highest value and the lowest value. So just make a statement that this was the most popular thing and this was the least popular thing, or this one used the most energy and this one used the least energy. There you go, you've got two statements, nice and easy. Okay, let's look at our first example. And that's going to be this two-way table that we looked at yesterday. So we created a two-way table where we had two pieces of, well, actually more than two pieces of data, but two variables. So one was gender, so male or female, and the other was a video game console or a device. And then here are all our different options for that. So we put all that into a table, and we could make a few statements about it looking through this table. We saw that PlayStation was the most popular for males, whereas for females, the phone or smartphone was the most popular. Today we're going to look at how this looks in a two-way or side-by-side, I should say, side-by-side column graph. Okay, so what I've done here, instead of just having numbers for these columns, I've actually converted it to percentages because it's a lot more interesting. It means a lot more for people to go, okay, let's think about the percentage of males who preferred PlayStation over the ones who preferred a Nintendo or so on. Makes a little more sense rather than just these kind of numbers somewhere between 0 and 1,000. So you'll see here on my y-axis, I've got percentage of respondents, and it actually goes by intervals or markers of 10%. It doesn't go all the way up to 100. Otherwise, if I had it up to 100, it'd sort of be up here, and it'd have a whole lot of space. So as long as it starts from 0, and here it ends at 50, it doesn't really matter, it doesn't go all the way up to 100 because my highest value is 40, and everything else is below that. If I go all the way up to 100, these are going to be really small and difficult to read. Okay, so here we've got, this is our percentage of respondents on our y-axis. Here I'm going to consult this data label, this device type, so I can see all the device types, PlayStation, Nintendo, and so on. Over this side, I've got a key. It doesn't actually say key, but I can see that the blue columns represent the male respondents and the orange columns represent the female respondents. Also, I have a handy title, so every good graph should have a title, and it says preferred device for playing games, 10 to 18-year-olds by gender, so it's very specific. So what statements can we make about this data? What does this tell us about this sample of 2,000 people, half of which were male, half of which were female, and their preferred device for playing games? Well, firstly, we can say that phone was the most popular device among females. So let's go to phone, was here, and we can see this orange column is at 40%. Now, I actually put data labels on here, it makes it a lot easier. If you didn't have data labels, what you'd need to do is go to the Y column and then track across either with your eye or your finger or a pencil or whatever you're doing, and try to figure out what this column is. Depends on how precise the creator of the graph wants to be. I kind of like it with the data labels because it just makes it a lot easier. But here I can see that 40% of females preferred mobile phones compared to only 21% of males. So almost double the amount of females or proportion of females preferred mobile phones than their male counterparts. Conversely, I can see that PlayStation 4 was the most popular device among males, so 31%. And then what I'm going to do is I'm also going to make a comparison compared to 3% of females. So I'm making sure I'm looking at both of these columns here, so I can make a comparison there. So not only am I comparing, this 40%, this 31%. So this was the most popular choice among females. This was the most popular choice among males. I'm also looking at, well, what did the females think about PlayStation 4? Similarly over here, what did the males think about mobile phones? So it gives me all these options. And compared to females, this was over 10 times, 3 times 10 is 30, so it's over 10 times that percentage points. And lastly, this is the last statement. Now you can make a lot of statements about this data. I'm only going to make 3 today. PC had the smallest difference between the two genders. So let's go to PC here at the end. So 15% of males preferred PC and 9% of females preferred PC. So it was 6 percentage points. Make sure when you're comparing data that involves percentages and you're looking at the difference between the percentages, you always use this language percentage points. Don't ever just say percent. It's really important to make that distinction. Now it's okay here because we've got 1,000 males and 1,000 females, but you might have 200 females and 1,000 males. So it's very different to compare the percentages there. Okay, while PlayStation 4 had the largest difference. So here I'm not only looking at the smallest difference, which is here, I can also look for the largest difference, which is 31% and 3% there. So a difference of 28 percentage points. So that I can make all these statements just by looking at this two-way table. It's got a lot of really valuable information in here. If you are marketing or selling video game consoles, or you work for a video game company, this might be really valuable data for you. Okay, let's look at the other example we looked at on Monday, and this was about the life cycle carbon dioxide equivalent that's produced from selected electricity supply technologies. So whether that's a coal power plant, a gas power plant, a solar power plant, solar rooftop configuration, etc. Now here, instead of doing percentages, which wouldn't really work for this, what I've done is I've used their I think this is UN data, is using this thing about CO2 equivalent per kilowatt hour, which is a kind of value you can use to determine how much carbon dioxide or greenhouse gases this particular technology produces over its lifespan. So from when it's built to when it's decommissioned. So let's have a look. So here again, I've got my key. Now my key's down the bottom here. But you can see each of these columns, they have a color. So the blue is the minimum and the orange is the maximum value. Okay, so what statements can we make? Well, firstly, coal had a considerably larger minimum and maximum, sorry, coal and gas had a considerably larger minimum and maximum values than the other technologies. So here I can see, well, the minimum value for gas is 410, and its max value is 650. Same here for coal, it's 740 and 910 respectively. Whereas the next highest max value is 180. So that's actually quite a difference there. So I'm going to attribute some meaning to that. I mean, well, actually, that's kind of important. We need to know that. So always when you're interpreting this kind of data, look for the largest and the smallest, look for the greatest differences. That's where you'll really get the most valuable information. Gas technologies had the largest difference between their minimum and maximum values. So now I'm not looking across the different technologies. I'm actually comparing the minimum and maximum values for this one technology. Because I saw there was quite a big gap here. So I thought, well, do you know what? How does this compare to the other technologies? And I actually found this was the largest difference, a difference of 240. So I thought, you know what? That's a good statement. I'm going to make that statement. Somebody might like to know that there is this big variability between how much carbon dioxide an efficient gas station produces compared to one that's inefficient. Solar PV rooftops, that's solar panels on a household roof, had the smallest difference between its minimum and maximum values, which was 34. So again, I'm looking for the difference. This time, instead of looking for the largest difference, I'm going to look for the smallest difference. So here, let's go to, where is it, solar PV rooftop? It's just there. And the last one, wind onshore had the lowest maximum value, which was 56. So this is my lowest number. And again, I put data labels on here. You won't be dealing with things so complex today. Your eyes will generally have to track across, but you'll have grid lines to help you. Wind onshore had the lowest maximum value, while nuclear had the lowest minimum value. So here, there's actually quite a big difference between the min and maximum value for nuclear, but it actually has the lowest minimum value, whereas this has the lowest maximum value. So again, I can make these comparisons between these different technologies and then also these two variables, the min and maximum value. So very useful. There's a lot of information I can get from this. Okay, so here are the main ideas from today's lesson. Firstly, make sure you consult the graphs key when you're looking at it so you know what each color represents, what each column represents. Make sure you compare the heights of different bars in the graph to make statements about the data. And always try to identify the highest and lowest values. You can always make statements about those. Then what you want to do is you want to look for the greatest and smallest differences between different categories. So for example, a category could be Nintendo Switch and PS4 and variables. So the variables there, you could be looking within the Nintendo Switch category, and the two variables are male or female. Now today, with most of your activities, they're going to be answering questions that have already been written for you. So this was more an activity today. I just wanted to show you how you can make sense of a two-way column graph without having those questions to guide you, but still be able to make statements about the data. I think you'll find the questions today not too tricky. If you can do what I just did then, and actually I can look for the highest and lowest values, you should be good for today. All right, thanks for your attention, guys. Good luck, and I'll talk to you soon. Bye.